Welcome to my first virtual lesson. In this lesson, this is 4.1, we're going to talk about congruent polygons. And we're going to learn what it means for two polygons to be congruent. We need to start by going back to Chapter 1 and recalling congruency from Chapter 1. In Chapter 1, we talked about congruency of line segments. And we said that two line segments were congruent if their lengths were the same. For instance, I have line segment AB and CD up here. And I can see that AB and CD are in fact the same length there. So those two line segments are congruent. Similarly, I've got two angles here, angle 1 and angle 2, and I've got them both marked as 53 degrees. So these two angles are congruent because they have the same angular measure. And we could take these angles and we could actually overlay them and see that they do in fact match each other right there. So those two angles are congruent. And let's look back at our notation from Chapter 1. In this case, to annotate that segment AB is congruent to segment CD, I would simply write AB, line segment AB, I put a little line over it because it's line segment, is congruent, remember the equal sign with a squiggle over it, to line segment CD, which also gets a line over the top of it. And what that means is that the length of line segment AB, written AB, is equal to the length of line segment CD, which is written CD. And the length of AB and CD are equal. Now, why did I use an equal sign here instead of a congruent sign on the second one? Notice the first one, where I've got AB with a line over the top of it and CD with a line on the top of it. We're talking about the line segment there. Line segments are objects, and therefore they're congruent. But the length of AB, written AB without a line over the top of it, is just a number. It's the length of it. So AB and CD are both numbers, and therefore they're equals. So we use the equal sign there. Similarly, I can look at my angles here, and I can see that angle 1 is congruent to angle 2. That's because the measure of angle 1 is equal to, again the measure is a number, 53 here, the measure of angle 2. And I annotate the measure by putting an M on the front there. In this case, the measure of angle 1 is 53 degrees, and that's equal to the measure of angle 2, which is also 53 degrees. That makes sense. So let's extend this idea of congruency to polygons. What does it mean for two polygons to be congruent? Well, in short, it means I can take a polygon and rotate and flip it, whatever I need to do, and then in such a way that I can overlay it on another polygon, which is congruent, and the two should match evenly. All their sides should be the same, and all the angles should be the same. And you see clearly these two pentagons on the screen right now are congruent, because when I overlap them, you can see all the angles are the same, and all the sides are the same. And when we talk about two polygons like this, and we overlay them, the sides that are matching and the angles that are matching are called corresponding sides and corresponding angles, just like we learned in Chapter 2. Angles and sides in the same position are called corresponding angles and corresponding sides. Okay, before we go any deeper into that, we need to talk about the polygon and how we name our polygon. As we said, a polygon, it consists of a series of sides and angles. And each of the angles is a vertex for the polygon. In this case, I've got a quadrilateral, and a quadrilateral has 4 vertexes. And each of those vertexes is labeled with a point. So in this case, we've gone with a standard A, B, C, D labeling here. You can label them anything you want, but the norm is to take 4 letters in a sequence. Pick a starting point. In this case, we started in the upper left position there. We've called that A, and then we've gone clockwise around and labeled them B, C, D. And the way we name this is we pick one of our vertexes as a starting point for the name, and then we go either clockwise or counterclockwise around and list all the vertexes. In this case, we're going to start with point A, and we'll just work our way around A, and then B, C, and then finally D to give us the name ABCD for our quadrilateral here. But we could just as easily have called it quadrilateral B. We could have called it BCDA, Or I could have called it BADC, starting at B and going counterclockwise, as long as the four vertices are done in the proper sequence as you go around it, whether it's clockwise or counterclockwise. Okay, now let's talk about the parts of the polygon. The sides, just like we learned before, the sides are all segments. So the first side is going to be the side right here in blue, and it's going to be side AB. And it's just a line segment. It's AB. We put the line segment over the top of it. The side to the right edge here is line segment BC. So I label that BC. This one down here is line segment CD. Put the hat on it. You could also call it line segment DC if you wanted. It doesn't matter. Either way, as long as you use the two endpoints and the little line over the top. And finally, on the left side, we have line segment AD. Okay, it's also made up of 4 angles. In this case, we have angle A, angle B, angle C, and finally, angle D. So those are all the parts of your polygon. And the naming of our polygon is simply the 4 vertexes going around the polygon in order. This one we've called A, B, C, D. All right, now let's throw our first definition into the mix. Congruent figures, and we just talked about this a moment ago. Now we're going to formalize it here. Congruent figures are polygons with congruent corresponding sides, all the sides and angles. What that means is all the corresponding parts, whether they're sides or angles, are the same length or the same measure. When you start talking about congruent figures, naming becomes very important, and we have to use a similar convention here. In this case, we've got our previously named polygon quadrilateral ABCD, and with this one we started naming in the upper left corner, and we went clockwise around BCD. So if this other polygon, if it is congruent with the first one, and let's just check and see if it is congruent. We can take this one and we can put it over the top here, and we can see, sure enough, those 2 polygons are congruent. Okay, it becomes important now when I label my congruent polygon that I use the same convention. In this case, because I started with the left polygon in the upper left corner, I need to do the same thing on this one. So I'm going to start with L, and again I'm going to go clockwise around it. Okay, so I end up with LMNO as the name of my congruent quadrilateral there. And what this means is, on the name, each letter is a corresponding angle. So you can see the first letter in the left polygon is A, and the first letter in the name of the right polygon, quadrilateral, is L. And so therefore, because we know those 2 are congruent, we know that angle A is going to be congruent to angle L. Let's step back and let's write these as 2 congruent polygons. How do we do that? Well, we'd write ABCD is congruent to, there's our congruent symbol, LMNO. Now, there's a lot of information contained in this simple statement right here. Whoops. For instance, because I know that the letters in each name correspond to, or are corresponding angles, I then know that the first letter here and the first letter here are corresponding angles. So I know that angle A is congruent to angle L. And I can continue doing that through the name here. I could tell you that angle B is going to be congruent to angle M. Okay? Similarly, I can tell that line segments are going to be congruent. I can see here that I've got line segment AB as my first 2 there is going to be congruent to line segment LM because they're in corresponding positions in the name. Similarly, CD would be congruent to line segment NO. This is why naming your polygon is critical, and making sure you do it correctly, because people will infer from your name which parts are congruent to each other. Okay, let's take a look at a couple of geometric objects here and check and see whether or not they're congruent. Okay, these two circles would be congruent if I can take one circle and put it on top of the other one. Well, this time the green going on top of the yellow one there, and they come up to be equal. And we can see that this green circle just barely covers the yellow one, just nicely. So those two figures are congruent. Okay. Similarly, these two triangles may be congruent. Are they congruent? How would we tell if these were congruent? Just from looking at the picture, well, I said if I take one that I can rotate or flip to make it match the other one, then they're congruent. So let's take the blue one. Let's go ahead and rotate the blue one around a bit here. And let's move it over onto this one and see if they're congruent. Sure enough, we see all their angles are the same, all the sides are the same, so these two are congruent. All right, I can rotate this back just a bit. It doesn't matter. We know that these two are congruent. Okay, let's label these two triangles just to work on that idea. Let's start with the left one, with the blue triangle. And we're going to go ahead and name the first vertex the top one, the sharp end of the triangle. And we're going to name that A, and then we're going to go clockwise around it. So the next one is going to be down here at the bottom, B, C, or B, and then the final one is the left angle over here. We're going to call that angle C. Okay, so what we've created here is triangle A, B, C. Okay, here's where it becomes important that you use correct naming notation. Let's go ahead and name the triangle C, the red triangle here. Now let's go ahead and start in the corresponding position from the blue one. We start on the blue one at the very sharp end, which in the red case is going to be the upper left corner here. So we're going to go ahead and call this D. And again, we're going to go clockwise around it. So E and then F. Now if this were a mirror image, then I would have to go counterclockwise around. But in this case, they match each other. So we're just going to go clockwise around it. So D, E, F. And we're going to call this triangle D, E, F. Now recall, we could have called this triangle EFD or DFE, but in this case we have to call it triangle DEF to ensure that we have corresponding parts in the same place in the name. In this case, angle A, that's my green pen here, if we look at the left name, angle A corresponds to angle D, and they're both in the first position in the name. Angle B corresponds to angle E, and they're both in the middle position in the name. And angle C corresponds to angle F. So it's important what order you put the letters in when you're making the names up here. Okay, but once you do that, if I then go ahead and formalize this and I say the triangle ABC is congruent to triangle DEF, I've pretty much just told everybody that all these angles that are in corresponding positions are the congruent angles. So if I got rid of all the pictures and just told you that, you could infer from that that angle A is congruent to angle D, etc. Okay, now let's throw another theorem at you. This is called the third angles theorem, and it's a fairly intuitive theorem. What it says is if I have two triangles and I know that two angles in those triangles are congruent, then I know the third angle is going to be congruent as well. Let's think about this, why this is true. Let's take these two triangles I've got here, and I'll tell you right up front. We'll just compare them here for a moment. If I can move it. And it doesn't appear to want to move. Okay. Well, I'll tell you that angle A and angle E are congruent. So let's mark those as congruent, A and E. I'll tell you that angle B and angle F are congruent. So let's mark those as congruent. Remember, angle B and A are not congruent with each other, so I've got to use a different congruent symbol. So in this case, I'll use the double arc here. So that says that angle B and angle F are congruent to each other. And what the theorem says is that if I know that two of these angles are congruent, then the third angle, in this case C and G, must also be congruent. Well, this sort of makes sense because if you think about it, Angle C, if we look at the left triangle, angle C is going to, the measure of angle C is going to be equal to, well, angle A plus B plus C equals 180. So if I know A and B, then I can figure out C. I add A and B together and subtract that from 180. That should give me the measure of C. Well, I know that angles E and F in the right triangle are the same numbers as A and B. So if I add those together and subtract them from 180, I should get the same number. So therefore, I know that angle C and angle G also must be congruent because they must be the same number. So a simple theorem, it just says if you know two of the angles of a triangle, you know the third angle of the triangle. Okay. One last thought while we're looking at these two triangles. They both have all congruent sides. Are these congruent triangles? Are they congruent polygons? Well, let's have a look. What did we say congruent polygons need? They need to have all corresponding sides and all corresponding angles congruent. In this case, we know that all the corresponding angles are congruent, but we know nothing about the sides. There we go. Now we're moving. Okay, so we take a look at this. Yep, I can see, if I move it up here, I can see that angle A and E are congruent. If I put it over here, I can see that angles B and F are congruent. And if I move it down, I can see that angle G and C are congruent. And now I'm completely destroying my triangles. But we can clearly see that the sides are not congruent to each other. So therefore, those two triangles are not congruent. Something to keep in mind as we go into section 4.2, where we're going to be talking about how we tell whether triangles are congruent or not. If all you know are the three angles, you can have different sized triangles with congruent angles. So the two triangles don't necessarily have to be congruent to have congruent angles. Okay, let's look at an example here. Here are two triangles that share a side. Okay, and if we look at this triangle, several things we note. First of all, we see that the hypotenuse on each of the triangles is congruent to the other. We've got a little congruent tick there, so that tells us those two hypotenuses are congruent. We know the bases of both triangles are congruent because we've labeled them as congruent, so therefore it must be. And we know that the vertical leg of each triangle is congruent. Why? Because they share the same vertical leg. And by the reflexive property, we know that that leg is in fact congruent to itself. So therefore, the third side on there is congruent. Now, let's look at our angles. Okay? We know that angle ABC, which is this angle right here, is congruent to angle ADC, because it tells me there. I've got the little congruent marks. And because angle C or ACD, let's mark that one, this one right here, angle ACD is a 90-degree angle. It's a right angle. And because I know these two angles are linear, are a linear pair, and I know that ACD is 90 degrees, then ACB must also be 90 degrees. And therefore, those two angles are congruent. By the third angles theorem, because I know that two angles of this triangle are congruent, I therefore know that the third angle up here must be congruent as well. So now I know that all three sides and all three angles of my triangles are congruent, and therefore these two triangles are in fact congruent. Okay, let's go ahead and bring it all together and bring it to a close here. And then we'll start working in the workbook. Okay, I've got two triangles here, ABC and triangle DEF. If I write the fairly simple statement here, that triangle ABC is congruent to triangle DEF, then pretty much what I've told the world is that angle A and angle D are congruent. So I can put my little congruence there. I've shown that angle B and angle E are congruent. So I'll mark those as congruent, angle B and E. And I've shown that angles C and F are congruent. So I'll mark those as congruent. 1, 2, 3. And 1, 2, 3. And then finally, I can also do the line segments. I know that line segment AB and line segment DE are congruent. So there's AB and DE. I've marked them both as congruent. I can see the line segment BC is congruent to line segment EF. So I'll mark those. And of course, we sort of have to wrap around here and say that CA and FD are also going to be congruent. All that information is conveyed in this annotation right here. That's exactly what you read from that right there, that these two triangles, ABC and DEF, are congruent triangles. Okay, that ends this lesson. We'll go ahead and get the workbooks out and start working on some sample problems.